Hello everyone, it's the lab number 7. Today we're gonna study LDO regulator or low dropout regulator. So it's basically op-amp based circuit that can regulate output voltage. So let me show in an example. So the yellow one is output and blue one is our input. So what it does, it actually regulates and keep it fixed output, like let's say at 5 voltage output, yeah. It's a very actually useful circuit because sometimes we need like a stable 5 voltage, which we can use for example for powering any devices such as smartphones, any like battery based devices. But our input actually like not stable, like a sinusoidal, it has ripples, or even it like exceeds 5 volts or goes down 5 volts. So in order to regulate any input and always have an output fixed, let's say 5 voltage, the LDO is used for these cases. So today we're going to study how LDO works, and you're going to see and in practice how it works. Basically what you have to do in this lab, first you have to connect LDO, connect your power supply, connect signal generator. So you have to like do two BNC cables, one just directly to oscilloscope to see directly the input signal, and one goes to the LDO set frequency of 1 kHz. And this time, as you can see, I have a DC offset, so put 1 voltage peak-to-peak signal, but set your offset was starting from 5.5, and then increase your offset from 5.5 to 11 with a step of 0.5. So everything you can see, find this information actually in your like lab manual. So go to the chapter 11, find chapter 11, experiment 11, and here you can find actually the schematic of this LDO. And what basically you have to do in this lab, you have to like plot two plots. One plot is V out versus V in. So you're gonna change V in and see what is V out, and make take in consideration. So you're gonna change your V in, but your V out be around like the fixed value, but it should change slightly like with increase of V out. So take more precise values of V out. As you can see, it's 1.8, but it changes slightly like to the 4 digits after point. So you have to take this in consideration. So you should first plot this one, and for second plot you have to plot V out versus current out. So you're gonna change the load current. So in order to change the load current, you have to change the load resistance. So this time you keep V in fixed and change your resistors and calculate the V like the current. So let's first I'm explaining the first plot. What you have to do, so your first signal 1 kHz, 1 volts peak to peak, and the DC offset is 5.5, and you have to increase to 11. If you hit the limit of the signal generator, so just go to maximum V10 or whatever the limit you have on your oscilloscope in our lab. So you have to connect. So here we have V in, V out. V in, it comes from the signal generator. V out goes directly to the oscilloscope. Here the ground connection, you connect the ground connection to the ground. Make sure that it's on, and make sure it's 10. And the jumper connected to plus 10 voltage, and here jumper is connected to on. And it should on once you on everything. So once you connect, it's simple circuit, just need to connect V in, V out, and ground connections. Now what you have to do, you have to record different voltage offsets. So let me just decrease the range here to see like the amplitude. So as you can see, the voltage LDO is working, it regulates output. We have stable 5 voltage, even though the input is like ripples, the sinusoidal, that actually exceeds 5 voltage. So if we're going to increase, let's say the DC offset to say 7, and for the visualization we put 7 here to see how it looks like. as you can see here, it's on, it's on. So you see, it's on, yeah. After set, push to center, make the same scale. Yeah, as you can see, the input is increased. It's more than 5, it's like around 7, but output still around like below the 5 as it should work. So your goal is to change the in and port V in versus V out. So change your V in from 5.5 DC offset to 11 or 10 and put this port like this. For the second port, now you keep fixed your V in. So let's say V in be like 5.5. Okay, but now you should change the resistors. Since we don't have much different resistors, we're gonna take help of trimmers. Trimmers actually is very useful device. It's actually a passive device, but it can provide different variable resistance. So we're gonna variable have a range of different resistors. So your goal is to set this resistor trimmers from the 100 ohm to the 1k ohm with a step of 100 ohm. Okay, so you should take a jumper, connect output, just take this out, take this out, connect this jumper to the one of the pin of this trimmer, let's say to the S. So you have to measure the resistance between S and plus 10. Connect this plus 10. Connect output of the signal that goes to the oscilloscope to the another pin. And you should, by using the screwdriver, change the resistance from 100 ohm to 1k ohm, like with a 100 ohm step. You should record the output voltage. So for each step you record output voltage, then divide it by the resistor you use, you're gonna get the current. So for each current you're gonna record, and this port V out versus current out. So basically what you should get decrease of the V out when the current is increasing. Okay, so and one more point, in order to see how much resistance you have, you need to use the multimeter. It's pretty easy. You have to put your multimeter in the ohm and measure the resistance in these two connectors. Okay, so in the lab I'm gonna show how it does. It's pretty easy. So you set every time you measure these trimmers, and once you set 100, 200, 300 up to 1k ohm, connect this to the output of the LDO and measure the output. Okay, so this is that's it. So once you do it, the task for your home is going to be also simulate the circuit in the LT Spice. So this schematic of the circuit you can find in your lab manuals or in the PDF lab manuals which will be provided to you in the manual and in model. So that's it. Thank you very much.